Again everybody, today we would be discussing the basic block. As in the last video we have discussed the components of a blockchain. So what are the blocks basically, and how do we add those particular blocks when the blockchain transactions are being taking place? So the generation of the block, how do we add those particular blocks on the transactions in the blockchain? So first thing is, as we have discussed in the last video, the block is a record that contains transaction data detail. Like if I have to transfer some money from A to B, so it would have all those particular data as a record in the block. So in the last video we have discussed the block should comprise or consist of a block hash of the block, that is an alphanumeric value which uniquely identifies that particular block. If we are using SHA algorithm 256, then it generates 256 bit or 64 characters alphanumeric number. Okay, so hash of a block is which uniquely identifies that particular block. Then we have a hash of the previous block. As we have seen in hashing, we know that we would be using the hash chain. So obviously the hash of the previous block is necessary because that acts as a handle for connecting to the previous block. So handshaking or the handling of that previous block is being done by this particular hash of the previous block. Then the timestamp, that timestamp is the current time. Obviously, it is in hours, minutes, seconds, and sometimes in milliseconds also. The nonce, as we have discussed, that is a random number which is used to vary value of that particular hash. Okay, so the use of the nonce was if our hash value, generated hash value is greater than the target value, then we used to change the nonce. So nonce is a random number which we have to change when that particular target value is less and the hash value which we have generated is greater. Okay. Then we have discussed the Markle root where we were using the hashing, rehashing, and rehashing functions. So that was the tree. So we only require that particular root value, not all those particular subtree values. Only the root value that was there with the name of H0, that value would be here in this particular block. Then exactly these are the values. See, all these values are acting for security, for integrity, and for privacy of that particular block. Then comes transaction data. See, if I take equally likely for all these 6 particular details which are there in the block, then the transaction data would be 1/6. So each has 1 part, so 1/6 part for each. So that particular data, to send the data, to store that particular data, we require some of particular parameters so that the data should be secure, it should be integrated, there should be no discrepancy in that particular data, and the information of the sender and the receiver should remain private. As we lock our Facebook accounts, nobody could be able to see except our front page or except my ID. So that ID is there, but no other profile details are there in this particular thing. So we are keeping the privacy of this particular block by using all these particular 5 things, and we are generating a unique code each and every time. So uniqueness is also a parameter which is being considered along with this. Okay. Then this is how these blocks are being added. the first block in the blockchain, because every blockchain should have the starting point. So first block in the blockchain is called as the Genesis block. Genesis block is usually the first block where we don't have all those particular things because we don't have that previous hash values here. So this Genesis block, see, this Genesis block only has the hash of this first block. Obviously, this would be a fixed alphanumeric value. So this is acting, if I tell you in terms of the hash, this is acting as H0. That is first hash value H0, which we have seen in the hash function chain rule, and this would be 64 character unique alphanumeric value. Okay. Then see, we are now coming to chaining of these particular block. So this particular, and this is called as the block header, and this is called as the block data. Okay, so in the block header we have only that unique hash which we have generated, and that particular that would be added, and we would be broadcasting that particular hash value to everybody along with this particular block. So here this particular H0 is acting as an input. Here H0 is acting as the input. This timestamp is TS1. The nonce created is N1. The root, Merkle root is MR1, and the data which is being there. Using all this particular thing, we are again generating, we are using that particular hash function, and we are generating a hash which is new hash function that is called as H1. Okay. So now we have H1. When I am broadcasting this particular block, I would broadcast H1 along with all these particular block. The whole block is being transferred so that each and every node in this particular blockchain has their local copy synchronized with each other. They should have, because we have a distributed database, distributed ledger in this particular blockchain. So when the miner, who is the winner, who has generated this particular unique hash value, should transmit this particular new block, adding to its particular database also and sending it to everybody so that they can add to their local database also. Okay. So here again, see, this is H1. Now the next code which we have to use is H2. We are again using H1 here, new timestamp, new nonce, and new Merkle. Because we can have randomly selecting our hash functions, or it can differ from person to person. If this hash was generated by person P1 and this file is generated by P5, there would be definitely a difference between the hash functions which is being used by this P1 person and the hash function used by this P5 hash person. Because there are n number of hash functions, maybe because we want to make that particular data secure. For example, if I'm telling this has used 5 hash functions, okay, and this person has used 7 hash functions, maybe the same. All these 5 hash function can be same or maybe different. Here the 7 hash functions can be same or maybe different. If assume this has also 5 hash function, maybe it has used 3 of SHA and 2 of SSL, and here he has used 2 of SSL and 3 of SHA. So maybe different for each other, because they generate a unique key from person to person. These hash values differ. Okay. Now we have H2. Now I have to see. Now I have generated this H2. Now this H2 is acting as an input or the handle to the previous block. New timestamp, new nonce, new Merkle root, and then we have generated H3 as a new hash code along with the transaction. Obviously, transactions are different each and every time. Here the transaction is 1, here the transaction is 2, here the transaction is 3. Maybe in the first P1 is sending money to P2. That can be the first transaction. Maybe then P8 is sending money to P7. That would be next transaction. So here the transaction 1 would be P1 is sending money to P2. That is the transaction for which we are generating this. Here it can be P8 is sending money to P7. So this can be the transaction. Here P18 is sending money to P4. So these are different things which we are doing it. So transaction data definitely differs, and obviously we are using this particular hash values. Now comes, how can we do this particular thing? Now again, here this particular block is being used. I would come out to be. Now see, when we have these particular different blocks, how these blocks are being we have compared the first thing which we have discussed, that the blockchain resembles linked list. I've told you this. So what does the blockchain resemble? The blockchain is resembling the blockchain is resembling linked list. So what does the linked list have? They have the node, the data value along with the connection to the next node. Then again this connection to the next node. So for each and every node I had N1 node, then data of this, data of the N1 node and the pointer to the next. Then data of the next node and pointer to the next. So here see, we also have a pointer to the next. But what is the pointer which is acting here for making that particular as a linked list or a chain is the previous header. We are connecting it by previous header. So this, I told you, this is acting as a handle from previous to the next block. Again see this block header, this hash code which is being generated is acting as a handle. So we are connecting one block. This one block is connected to the second block by the hash value of this particular block which is being connected. Then if I generate B10 block, then this particular hash value will act as a handle for the B10 block. Okay, so the blocks are being connected together like the linked list, the data structure which we have compared in the first video, and this is acting as a handle to connect it from one node to another node. One more thing which I have to discuss here is basically we have seen that these were the nodes, and when we told we are having two types of nodes, and the nodes which were two types were, if you remember, I had two types of node. One was having a full node and the second was a partial node. Okay, so full node will definitely have this B0 block, B1 block, B2 block, B3 block and B4 block. The whole blocks would be there in this particular full node. Nothing would be separated. But in the partial node, I would have a B0 header. This is the block header. I would be now telling it in the short form. Then B1 block header. Then B3 block header. Then B1, B2, B3 block header. And then B4 block header. So we are having only the block headers in our partial or the light node because of memory problem. Maybe that is a new user and doesn't want to know the history of all those particular transactions or the distributed ledger which is there on their PC. So from the partial node, we have two issues. One, we don't have a memory space, or second, we are a new user and we don't want to know the history of who all have done what all transactions. So we are keeping only this particular header, that is the hash value, not anything different. So this block header is uniquely identifies this particular block because this block header has all the information, the previous hash value, then the timestamp, the nonce, the Merkle root and the transaction data which is being taking place into that particular block. So this block are being added by the hand checking, and so it is called as by chaining. We can tell we are chaining. Like we play a chain game in a ground. So this is chaining. We are handshaking with each other. So this handshaking, and so we have a block chain of all these blocks, and so it is called as the blockchain. We have moved from here. Usually one question, interview question which comes here, that how do we move from a hash chain to a blockchain? So for that, the basic answer here is that we are moving from a hash chain to blockchain. How we are doing it? See, agar practically if I tell you, we are using this hash value which is chaining. See, we are using this hash value only for chaining. The previous hash value, the S0 hash value is going to the next, and that is only acting as a handle or a handshaking part. We have generated a new hash code contained into one packet, packed them into one packet along with the previous hash, which was unique, and created a new hash H1. Again, this H1 is being packed with next transaction data, and then new packet is created, a new block is created, and that is again uniquely identified by some another value, another 16-bit alphanumeric value. So in this particular transaction case, we are moving from hash chain, because then we are bundling up all these data along with the hash value, and that bundle contains the timestamp, the nonce, the Merkle root, and the transaction data. Then we are bundling up together, then creating a new hash unique value for secrecy, for privacy, for security issues, and that particular value along with the packet is being transmitted to each and every person who is there in that particular blockchain. So basically we are doing hash chaining, but bundling all those particular hash values along with some another contents in that particular packet and generating a new block, and that block is being transferred from one person to another person, or it is being broadcasted. Here there is one more thing which comes into picture. Here I told you that I have only P1, P2, P3, P4 and P5. 5%. If P3 is winner, or he has generated the block, if P3 has generated a unique hash code which has a value less than the target value, then P3 becomes the winner, and so he is called as the miner of that particular blockchain. And so now he would broadcast this particular block value to each and every person in the blockchain, and they would add to their local database. Okay. So here, if I have considered only a small case, a small blockchain of 5 people, but assume I have a blockchain which contains approximately 1 lakh people. I have 1 lakh people in this particular blockchain. Should P3 transfer this particular data to each and every node in the distributed environment? No. P3 doesn't do to all those particular nodes, because P3 may not have a direct connection with P498, with P487, with P5832. So that P3 may not have a direct connection with these particular person. So P3 would broadcast this particular block which has been generated, or telling that he is the miner for this particular block, to only a group of people. Assume I tell that we will send to 10% of the people in that particular blockchain. So P3 sends to 10% of the people in the blockchain. Okay. Or if I decide that P3 will send to 1000 people in this particular blockchain. Now that 1000 people will send to next 1000 people, then that next 1000 people, 1000 into 1000 would send to next, until and unless each and every person in that blockchain has that particular block. So this process that P3 doesn't itself broadcast this to each and every person in the blockchain, this process is called as flooding of the blocks. So this is the practical approach which is used by Bitcoin. So Bitcoin uses this, but the processing speed of all these particular nodes which are there in this particular network, blockchain network, is so fast that within milliseconds, P3 sends to 1000 users, and within again milliseconds, that 1000 users sends to again, each and every person sends to again 1000 users, and we reach to all the community which is being connected to that particular blockchain. We are specific to a blockchain, not we have to broadcast to each and every person on the globe. But that is the scenario that in that particular blockchain, the persons who are there, it would be broadcasted to you. Okay, so here the flooding of the block means we are broadcasting this hash value or the winner value which is being generated by this particular miner. Okay. So now the genesis block is usually the first block, only block with no hash value of the previous block. See, we don't have any hash value of the previous, but we have generated. The genesis block contains transactions that are combined and validated to produce a unique hash. So we have this hash value, and having this particular hash value makes it uniquely. So first block is usually called as the genesis block. This genesis block doesn't have a previous hash value of any of the block, but it contains the transactions that combine and validate the transaction which is being produced for that particular hash value. The genesis block hash, along with all the new transactions, uses that particular hash value as the base value, and then the process use as input to create a new hash value. See, here we have used this particular hash value. We have used this particular hash value of the first block to generate the hash value of the second block. So similarly, this second block is having that particular hash value which has a base of the hash value of the first block. So obviously we are having this value into some other form. The value of this in some other form in this hash, because we would be using this hash as the input. So this H0 maybe we are rehashing. We have rehashed this H0 and generated H1. This H1 is being rehashed and generated H2. So we are rehashing, but kahin na kahin, at any point of time, we can come back to this particular H0 because that was the first block. So we have some traces of that particular value. If we want to see if we belong to that particular blockchain, we have to traverse back. This way. We have to traverse back from the previous block, and we can see that particular data, what is there in the genesis block. So in the genesis block, we create new transactions are being processed using that particular hash value, and that hash value acts as an input to the next block, that is the block 1. The header, which was the hash which was created by the block 1, will act as an input to the hash which can be created for the block 2 in the new transaction. So this defines the chaining rule. This goes on with each and every block which is being linking to the back to back, and we have a previous block via this particular hash value, thus forming a chain and leading to the back to genesis block. So this continuous linkage makes it impossible for any malicious actor to alter the information or insert any block between the two existing nodes. So if I have this particular value, this block B1, and then this is block B2. If somebody wants to add some particular block that is here, we cannot do it because this hash value is acting as an input to this particular block. So we should know all those particular hash values, and we cannot imbibe that particular, because this hash value, if he wants to insert, any malicious attacker want to insert, then this hash value would be acting as an input to this node. So obviously we should know that this chaining rule is so much. It is not here the word impossible. I should say it is not impossible, but it is not. I should say not possible, but it is not feasible to generate it. Impossible is not, because if you have a computing power and we are into it to break that particular code, we can definitely do it with the high processing power and the computing power which we have. So to do all those, the connected blocks can need to be altered as well. If I'm doing some or making some changes here, then obviously all the connected blocks would have a change, and that would defend the rule of tamper proofness or the integrity of that particular data. So we usually don't do this in a blockchain. As a result, each block strengthens the previous block, including the security of the entire blockchain. So we are having a secure transactions, and we are looking into this main aspect here is security, tamper proofness. Nobody should delete, or nobody can add, or nobody can update anything in that particular block which we have generated. A bigger chain means more blocks would needed to be changed. Bigger chain, and if you are adding something and telling that there is an update, so we have to change more of the block. And so if that is means somebody else is trying to tamper the data, somebody else is trying to compromise that particular data, and so I'm making a change into that. See, if I have B1, B2, B3, and we have a block of 100, chain of 100 blocks, and if somebody comes and tells, oh, we have done something wrong in the B3, so I have to change everything from B4 to B100 in that particular chain. If I add something in this B3, so we have, means if somebody is trying to change B3, obviously they are tempering that particular block, trying to change, they are compromising the data which is there in that particular block. And we can know the culprit, and we can find out who is the malicious attacker, and we can remove that particular person or warn that particular person in the blockchain. Okay, so this is all for the how we generate a blockchain, how we add that particular block in the blockchain, and how that particular name blockchain came. How the hash chain can be converted to a blockchain. We have answered all these questions in this particular video. In the next video, we would be seeing how exactly the transaction takes place and what would be the potential applications of the blockchain. Thank you for this video.